A very good afternoon, students. I'm Shweta
Students,
Singh, and
I'm
I warm.
Shweta.
Who has turned on the mic? I can hear my own voice. Okay, so I warmly welcome you all to Q&A session, and this is our second session on chemical reactions and equations, isn't it? So I can see that I think Devi Maya was not there in the last session, is it? Am I wrong, Devi? I hope I'm reading the name. Okay, okay, right. Fine. So Jovin was there, Ragvi was there, Raghul and Ragvi, you were in the yes, morning batch itself. Yeah. Okay, fine. So let's have a recap what we did in the last session. We discussed what is chemical reaction. We saw what is chemical reaction, and after that we saw observations to determine chemical reaction. This is what we did, but I believe we had to do examples to find out. We saw few activities on which basis we actually decided, okay, there are some observations. By looking at those observations we can find a reaction has occurred, right? But we need to find example for each of the observation. Before we move ahead, I would like you to solve this question. I think you won't be able to because we haven't done the example of this. Let's do the example first, right? Let's do the example first. Then we will move to the next one. Just give me a second. I'll show you a few examples. Yeah. So I believe we discussed about this in the last session. The observations
Yes,
to
ma'am.
determine whether a chemical reaction has taken place. So we discussed that, okay, there is change in state, right? There is change in state. There is uh, evolution, change in color. Then we have the evolution of gas, change in temperature, and formation of precipitate. And after that, one more I told you, evolution of light. Okay, so coming to the first one, change in state. Change in state. One example you can see here, that is ammonia reacts with HCl to give you ammonium chloride. Now, listen carefully. This is not the way we should write ammonium chloride because, wait. Okay, so we should write subscript. 4 should be our subscript. So, like this, ammonium chloride. So, we call it ammonium chloride. Ammonia is gas. Even HCl, you take it in form of solution in water. So when one is in solution form, other is in the gas form, but ammonium chloride, you are going to see the crystals of ammonium chloride, right? That's the change in state. Another example we did for the change in state, when we actually added zinc into dilute sulfuric acid, we got zinc sulfate and hydrogen gas. So we didn't take gas as the reactant, but when the reaction occurred, then a gas was formed. So this is the observation where we saw change in state during a reaction. This is one of the example. Coming to the second one, change in color. A very good example for change in color. When you dip iron metal into zinc sulfate solution, copper sulfate solution. Okay, copper sulfate solution. AQ means aqueous. Now, what's the color of copper sulfate solution? That's blue in color, right? That's blue in color. Have you seen copper sulfate solution in school? Ragvi, Ragul, Devi, Joven?
Maybe Joven. No, ma'am. No, ma'am.
No, you have no. Okay, so it exactly looks like you are seeing it here in the slide, right? So it's blue in color. And once you dip iron nail into it and keep it for 1 hour or 2 hours, then what happens? Reddish brown color deposition is seen on the surface of copper. That's nothing but the copper depositing over the iron. And the color of the solution is now getting green, right? The color is changing from blue to green. Why? Due to the formation of ferrous sulfate solution. So basically what is happening? We took iron and dipped it in copper sulfate solution. After that, iron sulfate means ferrous sulfate is formed with copper getting deposited on the iron nail. So copper sulfate solution was blue in color, whereas ferrous sulfate solution is green in color. So this is one of the example where you see change in color. So I hope you are writing down all these examples. Yes or no?
Yes.
Okay.
Yes, ma'am.
Good.
Yes, ma'am.
Good. Okay, now third is evolution of gas. So we just saw evolution of gas. One example was when we took zinc and we added sulfuric acid, we saw hydrogen gas getting evolved in it, right? One more example here where we took, we actually started heating lead nitrate. We are heating here lead nitrate, that is PbNO3 whole twice. So when you heat lead nitrate, you get lead oxide, that is PbO, plus NO2 and O2. So this is how it looks. You can see the brown fumes coming out of the test tube. Right, when you are heating lead nitrate, you can see brown fumes coming out of the test tube. So these brown fumes are of nitrogen dioxide. So whatever, the point here is when you heated lead nitrate, you saw the evolution of a gas, and that was the indication, okay, some chemical reaction is going on. Okay, so next one, I hope you wrote the examples here. Fine. Now, next one, change in temperature. When you mix calcium oxide, that is quicklime, right? Quicklime is the other name for calcium oxide. Even quicklime is also known as lime. So most of the students don't know this thing. The lime and quicklime both are calcium oxide only. So when you add water into it, the temperature of the beaker rises. It means heat is evolved. Right? Heat is evolved or heat is released during the reaction. So that's the indication some reaction has occurred. So what we took here, calcium oxide, and we added water into it, and what was formed? Calcium hydroxide. Right? What is the common name for calcium hydroxide? Anyone?
Lime.
Exactly. It's slaked lime. Okay. So the change in temperature is another example where we see that a reaction has happened. Okay. Next one, formation of precipitate. So very good example we did in the last session. We took potassium iodide, we added actually lead nitrate solution into it. So potassium iodide solution, lead nitrate solution, when they were mixed together, we got yellow precipitate of PbI2, right? Lead iodide. And potassium nitrate was formed there in the solution form. Understood? All the examples?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So this could be a question in your exam also, right? He give one example where you observe the formation of precipitate or change in temperature. Fine. Or they can simply ask you write two observations with example to determine a chemical reaction. Okay, so here comes one question for you. A student adds potassium iodide to lead nitrate in a test tube. What visible change confirms that a reaction has occurred?
Option C.
Option C, ma'am.
Option C.
Very good, very good. A yellow precipitate is formed. Okay, next one. A student is performing an experiment where he burns a magnesium ribbon and observes the formation of white ash. Which of the following statements about this reaction are correct? A new substance is formed, which indicates a chemical change. The white ash is formed, that is magnesium oxide, showing that magnesium reacts with oxygen. The reaction absorbs energy from the surroundings, making it an endothermic process. A gas is released, proving that it is a physical change.
Option B, ma'am. Option B.
Okay, option B. So what's wrong with option A here? What's wrong with option A here? Do you think that there's something wrong in the option A? Yes. Do you think there's something wrong in option A? Or no?
There is no
Come
wrong
on.
in option A.
Okay, so it means you think that there will be something wrong in option B?
No, there is no wrong in option B.
Exactly, both are correct here. Both are correct. A new substance. See what is happening when you are burning magnesium ribbon, magnesium oxide is formed. A new substance is formed, and that's definitely a chemical change. So option A is correct. Magnesium oxide is nothing but the white ash, and it is formed by the reaction between magnesium and oxygen. That is also correct. So it's basically multi-choice question. So both A and B are correct. Okay, there's a term called endothermic. During a reaction, when heat is absorbed, right, we call it endothermic. When heat is released or evolved during the reaction, we call it exothermic. Okay, so what do you say when we added water in quicklime? Is it endothermic or exothermic? When we added water in quicklime. Remember, there was change in temperature. The beaker got heated up. The temperature of the beaker actually rose that time.
Exothermic.
Exothermic.
Exactly, because heat is released, and that's why the beaker become hotter. Okay, very good. Fine. So we did this question. Now coming to the question what I was speaking about. Let me change the PPT here. Yes. This is the question. Oh, I gave you the answer. Why did I click? Yes, change in temperature can be seen in case of, do we see change in temperature when magnesium reacts with the dilute sulfuric acid?
No, ma'am.
No.
No?
No, ma'am. I think no.
Ki reacts with lead nitrate? Ki reacts with lead nitrate? Or change in temperature when SO2 reacts with acidified potassium dichromate? Zinc granules. Okay, let's do other way round. Let's do other way round. Here, what is happening? Magnesium is reacting with. Just give me a second. Yeah, let me check. Can I write on it? Wait. Yes, now tell me. Magnesium reacts with sulfuric acid, dilute sulfuric acid, and gives you magnesium sulfate plus hydrogen gas. Okay, now this question, second reaction, Ki, is it visible to you?
Yes, ma'am, visible.
Okay,
Yes,
so
ma'am.
Ki reacts with lead nitrate to form PbI2 KNO3. Okay, so SO2 reacts with potassium dichromate, acidified, so it's a big reaction. Simply, I can say that here, potassium sulfate, chromium sulfate are formed. Okay, next one, zinc reacts with dilute sulfuric acid and gives zinc sulfate plus hydrogen gas. Okay, so now let's match reaction with each of them. The first one, magnesium sulfate reacting with dilute sulfuric acid. So is there any change in color?
No,
No, there is no change in color. Formation of precipitate? No, no precipitate is formed. Yes, a gas is evolved during it, isn't it?
yes, ma'am.
A gas is evolved during it, and that gas is
Yes.
hydrogen gas.
Hydrogen gas.
Okay, yeah. So is there any change in temperature?
Yes, ma'am, I think.
Yes, whenever metal reacts with dilute sulfuric acid, right? Basically, acid. Whenever metals react with acids, there is rise in temperature. Basically, that is exothermic reaction. So magnesium is a metal in which you added acid, so it will be exothermic reaction. So there will be change in temperature. Okay, next one. Ki reacts with lead nitrate. So let's start once again. Is there any change in temperature?
No, ma'am.
No, ma'am.
No. Evolution of gas?
No,
No,
ma'am.
ma'am.
No gas is formed. Formation of precipitate?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yellow
Exactly. So
Red
it's
precipitate.
yellow precipitate. Yellow precipitate is formed. Right? So change in color?
No, ma'am. I
No.
think
Actually,
No, ma'am.
the yellow precipitate was formed, and for that we already marked formation of precipitate. Next one. Okay. I won't tell you third one, but the fourth one. Can you answer fourth one?
There will be change in temperature and evolution of gas.
Change in
ma'am, for fourth one.
temperature and evolution of gas.
Exactly. It's same as the first one, right? Metal reacts with acid. So there is evolution of gas, hydrogen gas, and there will be increase in temperature, basically exothermic reaction. Fine. Now coming to this reaction, SO2 reacting with acidified potassium dichromate, that's the change in color, right? Change in color. So the potassium dichromate color actually changes here. Fine. If I'm not wrong, it changes from yellow to green, but I'll confirm it. But there is change in the color of the potassium dichromate solution. Understood?
Yes, ma'am.
Yes,
Okay.
ma'am.
Fine. So this is how you can get a difficult question for this type of, you know, topic. Okay. Now coming to the assignment. I gave you two questions as assignment. The first question was, why do fireflies glow at night? Right? Do you remember?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So what will be the answer here? Did you try to find out the answer?
Yes,
Yes,
ma'am.
ma'am.
So have you got the answer? It's written over here, but I would like you to explain what have you found.
They undergo a process called bioluminescence.
Mm-hmm.
And a chemical reaction will take place inside their
Yeah.
body. So during that
Yes.
time, oxygen combines with the luciferin protein with the help of an enzyme luciferase and with the ATP molecules. So which results in the product's formation of oxyluciferin and AMP, adenosine monophosphate, and light. So this whole process is called as bioluminescence.
Yes. So basically, Joven, you are absolutely right that by the process of the bioluminescence, it actually glows. But we are learning which chapter? Chemical reaction. So we need to focus on the chemical reaction which is going on. So Ragvi explained in at least one essay form. How many words were there? 500, Ragvi? Am I right?
Probably.
Okay. So anyway, so what are the keywords here? So why do fireflies glow? Because they have a special kind of protein called luciferin, right? They have a special kind of protein that's called luciferin, which undergoes oxidation, basically reaction with oxygen, and that needs an enzyme, right? That's need an enzyme. Enzyme is something which increases the rate of reaction, and enzymes are found in living beings only. Do remember, enzymes are found in living beings only, and they increase up the biochemical reactions, rate of biochemical reactions, right? So the enzyme, what is there? Luciferase. It's okay. So luciferin actually get oxidized, or it reacts with oxygen, and during this reaction light is emitted. During this reaction light is emitted, therefore flies glow at night. So have you understood? In very simple way I explained why do fireflies glow. Okay.
Yes, ma'am. Understood.
Second question. Grapes hanging on the plant do not ferment after being plucked from the plant. I am knowingly coming in the front of the board so that you don't see the answer completely. Under what conditions do these grapes ferment? Is it a chemical or a physical change? What's your answer? Rakul, have you tried?
Yes, ma'am.
Yes, tell
When
me.
grapes are attached to the plant, when the grapes are attached to the plant, there will be aerobic respiration and the oxygen reaches there. But when plucked, there will be no oxygen will be in the cell, and therefore fermentation starts.
Very good. Very good. So basically, grapes, when they are attached to the tree or to the plant, they are living. And when they are living, they undergo aerobic respiration, means the breakdown of glucose is happening in the presence of air. Okay. But when they are plugged, then they undergo anaerobic, right? They undergo anaerobic respiration, during which what is formed? Alcohol is formed, and that is called fermentation. And that's why we say that grapes are fermented, and it's a chemical change. I explained the fermentation process in last session. Do you remember?
Yes,
Yes.
ma'am.
Yeah. So
The start of the last
that,
lecture.
yeah, that's the anaerobic respiration going on, and that's nothing but the fermentation, and fermentation is a chemical change. Okay, so let's move on to the topic of the day, that is chemical equations, right? Chemical equations. The prerequisite, you should know what is a chemical reaction. We discussed it in the last session. Do you know what is valency? Do you know what is
The
valency?
combining capacity of an element.
Very good, Jovin. It's a combining capacity of an atom, right? So the valency, how do we find valency of an element?
By arranging
Using the number of
electrons.
electrons.
Sorry? What did you say? Valency is basically equal to number of electrons in valence shell, or if they are more than 4, then 4 minus number of valence electrons, means which are present in valence shell. Do you remember these formulae? Do you remember?
Yes.
Okay, fine. And what about the valency of ions? So whatever the charge present on the ions, that behaves as valency. Okay, so how do we use valency to find out the chemical formula? That is important. So if I say that I have ammonium ion, so that's NH4 plus, and I have carbonate ion, that is CO3 2 negative. How am I going to build up the formula of ammonium carbonate? So ammonium has got +1 charge. So that's the valency of ammonium. Carbonate has got 2 negative charge. So 2 is the valency of carbonate. I will use crisscross method and I get the formula NH4 whole twice CO3. Understood?
Yes.
Okay, so this is something which is needed to study this particular topic. So not the balancing, but writing, I would say, writing a chemical equation can, 1 mark question can be asked from it. Okay. So we will learn how to write chemical equation. Balancing will be learned in different session. So before we start how to write chemical equation, as I said, you should know how to write chemical formula. To learn how to write chemical formula, you should know the valencies of the different ions. So if you don't remember, please learn this. Hydroxide, chloride, bromide, iodide, nitrate, bicarbonate, silver, sodium, hydrogen, potassium, they all have valency 1. Fine. So better, I told you in the last session also that you can follow the class 9 textbook, NCERT textbook, chapter Atoms and Molecules. There you'll get a chart of ions having the formula of the ions as well as their charges. So please go ahead and read that table once again. That is very important for this chapter. Okay. So you should know that copper and iron, there are others also, but we are more concerned about the copper and iron. They show 2 valencies. Copper show 1 and 2 and iron show 2 and 3, right? For example, if I write Cu plus, its name will be cuprous. If I write Cu plus 2, that's the second valency of the copper, we say it is cupric. Okay. Similarly, if I take iron, iron also show 2 valencies. Okay. So iron, if it is in +2 state, it is called ferrous. If it is in +3 state, it is called ferric, right? So what do you interpret from here? Here, in case of copper, the lower valency was +1. In case of iron, the lower valency was +2. So in case of lower valency, we used the suffix us. Whereas in case of +2, Cu +2, that's the higher valency. Hai na? In case of copper, +2 is the higher valency. And in case of iron, the higher valency is +3. For the higher valency, we are using the suffix ic. So that's why cuprous, cupric, ferrous, ferric. So for higher valency, we use the suffix ic, and for lower valency, us. Am I clear? How do we give the name cuprous, cupric, ferrous, ferric?
Yes, ma'am.
Yes, ma'am.
That's the basics of chemistry. So do write this if you don't know this thing. Okay. So does aluminium also show variable valency? What do you say? Do you think aluminium also show variable valency? No, it doesn't show variable valency. It basically show only one valency, that is +3. I'm going to erase it. Shall I erase it?
Yes, ma'am.
Yes, ma'am.
Okay, so aluminium shows only one valency, that is 3 only. Lead can show 2 valency, +2 and +4, but you don't have to worry about it. Okay, so now coming to the chemical equation. So first of all, there is a word equation. There is a word equation. Now, what is word equation? When we simply represent a chemical reaction in words. Right, in words, like we say magnesium plus oxygen gives magnesium oxide. This is word equation. When you simply write or you simply represent a chemical reaction in words, it is called word equation. Magnesium plus oxygen gives magnesium oxide. That's example. Okay, so left hand side we write reactants, and right hand side we write products. These are very simple thing, but we are not leaving any basic of the chapter. The reactants and products, they are separated by an arrow, to which we can read like it to yield. Magnesium reacts with oxygen to yield, and shows the direction of the reaction. The arrow is actually showing the direction of the reaction, what is being consumed. I mean, reactants are being consumed here and products are formed here. So we are showing the arrow towards the products. Am I clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Clear.
Now, as we saw the example, magnesium reacts with oxygen to yield magnesium oxide, and we said, okay, left hand side we have reactants, right hand side we have products, and we have arrow to separate them, right? But once we represent it with formula, right, with their chemical formula, and if we find that number of atoms, right, number of atoms for each element on both sides are same, right? If number of atoms of each element on both sides is same, we call it balanced equation. If they are not same, the number of atoms for each element, if they are not same on both sides, we call it unbalanced or skeletal chemical equation. So do remember what is skeletal chemical equation? That's unbalanced equation. So for example, like here, magnesium reacts with oxygen to yield magnesium oxide. So what do you think? Is it balanced or unbalanced equation? Yes, is it balanced? Unbalanced. Why do you think so? Why do you think so?
Because oxygen atom is 2 on the reactant side, but whereas in the product side, oxygen atom is 1.
Exactly, because the number of oxygen atoms on both sides are not same. For magnesium, they are same, but not for oxygen, right? So can I call it skeletal chemical equation?
Yes, ma'am.
Very good. So once I put 2 here and 2 here, now what do you say? Is it balanced or unbalanced?
Balance the equation.
So how many atoms of magnesium are there on the reactant side?
2.
And on the product side?
2.
For oxygen?
2 atoms.
And for both side we have 2, right? Very good. Okay, so how do we write a chemical equation? To write a chemical equation, first of all, we write products, reactants and products, right? We write reactants and products. So reactants on which side?
Left hand side.
Reactants are on
LHS.
left hand side.
Left
And
hand side.
products?
Right hand side.
Right hand side.
Right hand side. Okay. Then reactants and products are separated by an
Arrow.
very good. They are separated by an arrow. Okay. Next, 2 or more reactants, or if I say 2 or more products, they are separated by,
Less.
sorry,
Plus.
plus sign,
Yes.
right? They are separated by plus sign. If you have more than more than one reactant or more than one product, so they will be separated by plus sign. Conditions of the reaction are mentioned where? Like if I have to heat it, if I have to increase the pressure, or if I need any catalyst here, where shall I write the conditions?
Above the arrow mark.
Exactly, on arrow, right? On arrow. Like I used the triangle sign, that is to show heating. Okay, so I hope you understood how to write an equation.
Yes, ma'am, understood.
Joven, is it clear?
Yes, ma'am.
Yes, ma'am. It's clear, ma'am.
Okay. Dash of reactants and products to make reaction more informative. What is required? Their states. So as you can see, the state of magnesium is written here S in bracket. It means it is solid in state. For oxygen, it is written G in bracket, means it is gaseous in state. For magnesium oxide, it is written S in bracket, means it is in solid state. So physical states of reactants and products are written with them to make the reaction more informative. Okay, so that is done. After that, this is something you should know. What is the symbol for solid state?
Yes.
Yes.
Small s in bracket. For liquid?
Small L.
Small L.
Gaseous?
Small
G.
G.
Aqueous?
Small
AQ.
AQ. So aqueous means solution in water. Solution in water. Okay, now coming to the state. Now heat. For the heat, what symbol do we use?
Upward arrow.
Triangle, right? Triangle. Okay. Evolution of gas?
Upward arrow.
Upward arrow.
Yeah. And formation of precipitate?
Downward arrow.
Upward arrow.
Very good. So this is, I hope you are able to recall it nicely here with this table. Okay, so balancing is something we will do in the upcoming class. So right now, what have you learned so far? You actually saw how to write chemical equation. I hope there's no doubt. So this is something we'll do in next class, this portion. So writing a chemical equation was not difficult at all. So what we will do actually balancing chemical equation. We'll see hit and trial method as well as algebraic method, and we will find what information do we get from the balanced chemical equation. Fine. So you can do it later. I'm not giving you assignment right now because that assignment is related to the balancing. But what we did today, on this basis, you can go to the, but once you get the login ID, right, then only you can go to the assessment on the platform. On the platform, go to the science section. Here, look for the chapter. Which chapter do we have here? Chemical reactions and equations. You can view topics. Under topics, observe changes around us. That is something we did in the last class. Understand and observe chemical reaction in surrounding. This is something we can attempt, right? So you can simply go it and start practicing. Okay, so the more you practice on this, accordingly the dashboard will change on the daily basis. Your strength, opportunity, hurdles, weaknesses, all will be changed on the daily basis, the way you practice, and your MyQ score will be changing daily on that basis. Fine. So that's all for this session, everyone. I hope you understood whatever we did today.
Yes, ma'am.
Okay, so see you
Yes,
in the
ma'am.
next class, and then I'll give you a lot of homework related to the balancing. That's very important. Okay, so thank you. Take care. And do not forget to fill the Google form, which will be shared with you. Okay.